Okay, I'm going over number 1 this time in our exam 3 practice problems for calculus class. Thank you, Asia, for asking me to go over this one. I think this is a great problem. I've been waiting for someone to email me about this. All right, and right now it is 1:30. I just uploaded all 4.4 stuff. Oh, look at this. It's like a party in here right now. I see there are like 4 people in here studying. Awesome. But I did about, what? How many did I do so far? 3, 4, 5. Nobody asked about 6 yet. 7. So this will be my, 5th one. I mean, I ask you to please email me before like 3 or 4 p.m. today, 3 o'clock, so that I can record and email you something before I pick up my son. But 4.4 stuff is posted on Canvas for you now. For exam 3, though, you only really need part A. For exam 3, you only need part A. So if you're just trying to study for this exam, prepare for this exam for tomorrow morning, then just go through the first video where I go over the area of a region bounded by 2 graphs. Okay, that's the one that I'm going to put on your exam, number 8. But the second part, average value of a continuous function, it got a little bit confusing where I started using the exponential rules. But this part will just help you on 4.4 homework, my math lab homework, which is not due until this Sunday. So if you just want to focus on exam review for right now, you can just watch the 4.4 part 1 video. Okay, so that resource is available for you right now. But let me go ahead and start on number 1. Marginals and differential. This is what we did in section 3.6 a long time ago, right? We're not going to just evaluate cube root of 30 on our calculator. By the way, what is it approximately? What is cube root of 30? 30. It's about 3.107. It's about and that's from a calculator. I don't want that. Okay, if you give me that, I wouldn't know what to do. If you do that on the exam, I don't know what to do. I don't know. Because what we want is, we want to round this. We want to actually do this using calculus. We want to use that delta y is approximately f prime of x times delta x to find the decimal approximation of this. We're going to select convenient y value. And in fact, we actually selected convenient x value when we did the daily problem. But the daily problem was square root of, I think, 19, right? But I want you to try cube root of something on this exam. And who knows, I may ask you to change it to 4th root of something on the exam. I haven't really typed up your exam just yet, but it's just going to be 8 problems. And I'll probably try to keep it as similar as possible. But let's get to it. Let's get to it. I'm going to say that but first of all, what is a good perfect cube that we know of? Cube root of 1 is 1. We're not going to use that one. That's too far. What's the next one? Cube root of 8 is 2, right? And cube root of what number? 27 is 3, right? And then one more. What about cube root of 64? Isn't that 4? So you list couple cube roots. And you're thinking, which one is the closest? Which one is the closest to the one that I am given? And the closest one is this. I'm going to go with this one. So I'm going to use cube root of 7 equals 3 to approximate cube root of 30 because 27 is pretty close to 30, right? So my y value is 3. They said select the convenient y value, but we actually did convenient x value. The convenient x value is 27. And convenient y value is 3 because when I plug in 27 into the function, and the function is cube root of x, right? I get 27. So what's delta x? What's delta x? How far away is 27 from 30? Your delta x is 3, right? Because x plus delta x is that x value that we want to find. So 27 is 3 away from 30. So our delta x, our change in x, is going to be 30. Now, what do? We have to find delta y. We want to find delta y. What we're going to do is use that given formula. Find f prime of x times delta x. Okay? So find the derivative of y. Y equals x to the 1/3 power, right? So if you take the derivative of that, by the way, that is your f prime of x. It's going to be 1/3 times x to the, you have to do 1/3 minus 1, negative 2/3. So that's the derivative. I know, I'm so sorry. We've been doing the opposite direction for a while, right? When we started doing integrals, we started going backward. But 3.7, anything that has 3 in front of it, chapter 3, we were still doing derivatives back then. So that's the function. So what I'm going to do is I'm going to plug in my x value. So hold on. So f prime of x is equal to 1/3 times, I can write this as cube root of x squared in the denominator. Or I don't mind if you just use this one that you found. But if I just write this in a radical form without a negative exponent, it will be that. All right, let's find delta y. Delta y, the change in y is going to be f prime of, what was our x value? 27 times delta x, and delta x is 3, right? And we just found our f prime of x. So plug in 27 into that function. 1/3 times cube root of 27 squared. And we're going to multiply this by 3. And that is going to be the change in y. Okay? So some things will cancel out. This 3 will cancel out right there. I'll get 1/. Now, first of all, what is cube root of 27? Cube root of 27 is 3, right? 3 squared. So that comes out to be 1/9. Okay? So that's the change in y as x goes from 27 to 30. So what is cube root of 30? That's going to be cube root of 27 plus change in y, right? How much y changed? Cube root of 27 plus 1/9, which is 3 plus 1/9. So if you want to now give them the decimal, 1/9 is 0.111111. So the decimal approximation, I want you to round to 3 decimal places, right? So our decimal approximation is going to be 3.111, and that is the answer that I typed up for you on the answer key. So very similar to what you did for me, but then the one that you did for me back when you did 3.6 daily problem, that one was a square root function. Now I just kind of threw in a cube root function, but then the idea of adding the change in y to the convenient y value that was closest to the given, that one that we are trying to approximate, the idea is the same. So this is number 1. This is how you would do number 1. And just got an idea. Why don't I give you a 4th root on the exam tomorrow? Okay, so just like what Asia did, just like what many of you are doing for me, please let me know if you have questions. And I can't go over any more